Today, we will talk about statistics in perspective. There are appropriate uses for both descriptive and inferential statistics in educational research. Sometimes, however, either or both types of statistics can be used inappropriately. This chapter therefore discusses the appropriate use of descriptive and inferential statistics described in the previous two chapters. Normally, educational research is performed in one of two different ways. You can either compare two or more groups, or you can look at related variables within one group that are related. Furthermore, the data in any study can be either quantitative or categorical. We are going to discuss both quantitative and categorical data today. Researchers can compare two groups using quantitative data with the frequency polygons, the calculation of averages, or the calculation of spreads. We should prepare a frequency polygon for each group score and use these polygons to help us decide which measure of central tendency and the variability we should calculate. For example, the frequency polygon for the two different groups. If you are doing a study comparing inquiry methods and lecture methods might look like this. Once we have those descriptive statistics calculated, we have to interpret them. Consider the following to help you interpret the data. Information that is based on known groups, calculating the effect sizes of the groups, and using inferential statistics such as t-tests and ANOVAs, which we saw in the last chapter. We normally use scatter plots and correlations to relate variables within a group for quantitative data. When we look at correlations, these are the suggestions for how to interpret values. Check the example concerning scatter plot as well. Let's look at how we compare groups when viewing categorical data. We can use percentages or proportions, frequencies, or cross-break tables. A limitation of your categorical data is that evaluation is even more difficult than with quantitative data. Frequently, we will see a summary statistic known as the contingency coefficient. When examining relationships among categorical data within one group, I recommend constructing cross-break tables and calculating contingency coefficients. Most statistical software can be used to compute basic statistics that are discussed in this module. So let's just do a quick recap. It is frequently advised that graphical techniques before calculating numerical summary indices. This helps researchers see the big picture of the data. Using both graph and summary indices can help us more effectively interpret the results of a study. Make sure to use external criterion to help assess the magnitude of a relationship. The recommendation is to also use the professional consensus when evaluating the magnitude of effect size. If at all possible, we should consider using inferential statistics in addition to descriptive statistics if we have a sample-based dataset. Furthermore, using tests of statistical significance only to evaluate generalizability. When random sampling has not occurred, we should treat the probabilities as approximations or crude indices rather than precise values. We cannot generalize if we have not obtained a random sample. It's important to report confidence intervals if possible. Remember that at this point you should not have the confidence in going out and actually conducting data analysis. This is a broad introduction of related concepts.